Okay, so I'm Albrecht Schultz-Oska. I'm from the Ecology Department here. I'm a friend and colleague of Craig Buchanan. I'm a scientist. I'm confessing that. I will be chairing today's this afternoon session, Assessment of Endangered Species. We have three wonderful speakers here today. I will introduce them each in turn. First is Dr. Justina Ray. She is currently the Executive Director and Senior Scientist for the Wildlife Conservation Society of Canada. She has a PhD from the University of Florida. She is the co-chair of the Terrestrial Mammals Subcommittee for COSEWIC. COSEWIC is the Committee on the Status of Endangered Wildlife in Canada, which is the national body that designates, or at least makes recommendations to government about designation of species as being either endangered, threatened, rare, or what have you. She's an adjunct professor at Trent University, University of Toronto, and a research associate at the Royal Ontario Museum in Toronto. And she has worked on various government advisory panels. Those of you who were at the Science Cafe last night know that I had some questions about conservation priorities with respect to fuzzy, pretty animals compared to other less attractive animals. I can say with some confidence that Justina is in former camp. She works on things like wolverines and caribou and other charismatic megafauna. Is that unfair or a fair characterization?
Sometimes. Yeah.
Sometimes. No lichen though. We don't work on lichen. We're amphibians. We all like lichen. Okay, so Justina's going to speak to us today about challenging assumptions and definitions of extinction and recovery of endangered species conservation. Thank you all.
Hello, so I am now the second biologist to speak, and just speaking on behalf of a few of us who are huddled in the corner during these incredible talks this morning. We were feeling rather simple in our perspective and a bit exposed for the linear way in which we approach these things. And so I'm going to be the very first one to show you how simple and linear we truly are in comparison. But all joking aside, I'm very honored to have been invited here, and this is an extremely important opportunity to be able to discuss these issues together from these different perspectives. And so what I'm going to do here is I'm actually going to be speaking about two terms, extinction and recovery, and they cause implementers of endangered species legislation a great deal of angst. And my thesis is really going to be about how a very narrow and limited perspective on these two terms is actually quite dangerous in many ways for perceiving some of the issues that are going on out there that relate to conservation and also solving them. And so that's going to be the essential thing that I'm going to be talking about. If we look at the purposes of endangered species legislation, I've got SARA, the Species at Risk Act for Canada, up here to illustrate. They really are very much about prevention of extinction and recovery, but they're right in the purposes of the Act. And the difference between these is that extirpated and extinct are very well defined in the Act. It appears in the glossary, but recovery is not. And why this is significant will come evident, hopefully, as I proceed. With respect to extinction, this means everything in terms of both how we assess species, because it's a lot about risk of extinction, but it's also the end point that no one wants to get to, and also tongue-in-cheek, it's a way to get off the list, as this cartoon suggests. But it's obviously a huge focus of endangered species legislation, and many of the reasons why special acts occur for species that are deemed to be at risk. And a lot of the reason for that is the so-called extinction crisis. Although the interesting thing about the semantics of this term is that crisis denotes sort of a time-limited kind of immediate thing, but you can only perceive this crisis if you look at it through many millennia and compare what's going on today versus what has happened in the histories past. And what those scientists who have looked at these patterns have concluded is that what's occurring today is happening much quicker, on a much quicker time scales, and much larger magnitude in terms of species loss than has ever happened in the past. And we're talking about several orders of magnitude. And so the knowledge of that kind of crisis that's unfolding that we're in the middle of is a lot what is the impetus for really focusing on individual species that are in danger of extinction. And indeed, the whole discipline of conservation biology, which was founded really, although it had lots of seeds beforehand in terms of the seeds were planted long before, as we found out a little bit this morning as well, but the actual discipline, the name discipline, started in the 80s, and it was very focused on sort of issues about extinction as the endpoint, viability of populations, and really, really focused it, and also named a crisis discipline as well in response to the extinction crisis that was happening. So these kind of factors that were going on were very responsible for how the acts are designed now. And indeed, when you look at it, I'm not going to go into this at all because Marty's going to in the next talk a bit more dissect these criteria. But the international standard for assessing species at risk is really about factors that are related to extinction risk. And these are, so your mind, when you're assessing species, and the whole purview of that is really focusing specifically on how much risk a species has to extinction. And again, that comes from all of this. If we looked at extinctions in our lifetime, it doesn't really appear that much of a crisis, because if you're talking about species that have actually really blinked out and are gone, we can put them all on a graph. The numbers are not that huge, and certainly I've been in many rooms where that's been stated. Well, nobody went extinct. This project isn't that bad because nobody's going extinct. The problem is not so bad for the species because they're not going extinct. And indeed, that is a limitation of the word extinction, but yet we are very focused on that in terms of how we've constructed the act. And the process of extinction is actually much more complicated than the process is actually much more complicated and starts way long before any kind of extinction occurs. Extinction is the absolute endpoint. That's obvious to most of us, but we forget that when we've got the singular focus on extinction. And so, you can have site level impacts that start with various individuals, and that leads over and over, and the severity is exemplified by when the individual populations get affected, and then that all cascades and rolls up to actual extinction at some point. But that is a really long, protracted process, and more often than not, you don't even ever get there, or haven't in our lifetime. And how fast you get there, or it depends on so many things about the species itself, from the distribution to inherent characteristics of the species, its specialization, etc., and then of course the severity of the threats that it faces. But it is, there's a lot of things that happen before anything gets extinct. And so a better way probably to look at all this would be more in terms of depletion. And I was interested to see that, in fact, the social scientists that came before us, before lunch, have already figured that out. I mean, the extinction, in many cases, really embraced that broader, when they used that word, it embraced it in a broader context, so looking at depletion. And when we look at depletion, and this is just sort of one elegant way through the Living Planet Index, looking at trends of species, a lot more has happened than meets the eye since just the 1970s. And so obviously there is something going on very significant. And limitations of this extinction paradigm really become clear when you see a pattern that happens a lot, where you've got species that undergo very pronounced declines, and this is an example of 9 whale species that all exhibit the same pattern in the same period of time. And then they don't disappear, they're still there, but they're at much lower levels than they ever were before. Sometimes they've shown modest recovery, but it's nothing compared to what it used to be. And this is a very common pattern among a lot of our once abundant species, not all of them by any stretch, but a number of them. And, the whole sliding baseline phenomenon where you sort of forget the way it was. Well, we weren't living then, so that sort of helps. But even so, your whole life experience is not about these critters at a high abundance. So we're more celebrating what's going on down here at this level. This seems to us like a fairly significant recovery. And indeed, somebody already talked about the concept of functionality and what role does that species play, and how does that play out with respect to how abundant it needs to be in order to play that role very strongly. And that's getting more and more appreciated with the notion of functional extinction, and that in particularly these sort of wide-ranging, large-bodied animals and ones that are high at the trophic level are going to be feeling that first. And but obviously that's not that there's exceptions to that rule, but it's certainly something that we have to be worrying about. And then you've got, practically speaking, the difficult conundrum of so many unnamed species. That's in the light brown there, the sort of speculations about how many species in various taxa group that are yet to be named. We know they're out there. I don't know how they get quantified, but I'm showing the graph anyway. And then even worse, how many of those dark brown ones even receive any bit of monitoring at all across their range. So we don't even know what's going on enough to be able to understand those depletions or understand what they used to be and what they are relative to that point now. And then fundamentally, in practice, determining extinction has a very, very high bar. And that, we scientists have developed that bar ourselves. And extinct, if you're really literal about it, which we like to be, they're gone. And then, we've attached a 50-year timeline to that in SARA, for example, and that's pretty standard. And so you really have to actually not see one at all for 50 years. But in order to decide that it's gone for 50 years, you have to actually go look for it for 50 years, again and again. And so determining that is actually really difficult, and it rarely gets done in practice. And here's a great paper by Gerard Diamond in 1987, which sort of examined this in the tiny portion of the Solomon Islands and looked at all these species that had never been seen or documented since the 1950s, or a couple of them in the 1960s. And he determined through just sort of a back of the envelope analysis that if you took the sort of philosophy extinct unless proven extant, so basically, look, we haven't seen it, so it's extinct until we actually see it, then 12 of those species would be extinct. But if you did what is more commonly done, and which most responsible scientists would feel is the right way to do it, if you go extinct unless proven extinct, meaning like you have to, the burden of proof is fairly high in that regard, then it's really only one species of that is actually extinct. And so that does give a really good illustration about how different that can be, and the burden of proof. And then, what does that say about the overall metrics of the situation regarding how many extinct species there are? And then if the perception out there among the public in particular is that is the ultimate metric by which we should be measuring our concern for what's going on, then that gets problematic. Extinction risk also influences perception of success, and I put this cartoon on, as stupid as it is, for a reason, because bison is a great example of that. And in this schematic, it's like I don't understand. They hunt us to extinction, and now they want to protect us. And indeed, what protection means when we're talking about bison, which is, by all accounts, was quite an ecosystem engineer and really did affect the functionality of the system to a huge extent. Now is a shadow of itself, particularly in wild populations, and recovery aspirations are quite modest for many complicated reasons. And so let's parse out that a little bit more. I mean, recovery is not usually defined in legislation at all. It doesn't exist even though it's a purpose of the act, there is no definition of recovery. And that's quite common. But it is problematic because, you can interpret it in various ways. And we've gone through the exercise to do that, and I don't have time to go into that right now. But, you can talk about the ordinary dictionary meaning of the word. And you can also look a lot at the intent vis-a-vis sort of the purposes of the act and what that says, and try to marry that with biological considerations. And then, there's also the developing scientific understanding of what is required to secure the long-term conservation of species, and that's not always completely evident. What the legislation does do is it says that the recovery goal is supposed to be a scientific goal. I mean, that's what the scientifically derived goal. That's what Sarah sort of has by virtue of the fact that the recovery strategy is meant to be a science document, and that the recovery goal and population objectives or whatever are what's to be achieved, and that's supposed to be done in a scientific basis. But again, there's no definition for that. There's some policy about what that means, but it's very, very challenging to try and interpret that, and there's certainly many, many different interpretations. The ordinary meaning of the word recovery is not about status quo. It's about regaining or restoring something to a normal pre-harm condition. And it doesn't mean getting worse, and it doesn't mean staying the same. So if you really took the definition literally from the dictionary, it would be a lot different from how it's used normally. And indeed, our current ecological understanding is getting more and more so that, well, we understand how little we know, number one, but number two, we're taught the role of species in relation to the role they play in ecosystems and among communities is quite a bit more complicated than was appreciated before, notwithstanding the discussion this morning, which I found really illuminating, because there's obviously some way more eloquent scientists back then that sort of had a lot of this figured out in some ways. But what we're dealing with now, it is definitely a much different and more broader perception than what founded conservation biology 20, 30 years ago. And that plays itself out in a number of ways. And so there was one paper that came out not too long ago by a colleague of mine, Kent Redford, and many of his colleagues as well, about sort of looking at what does it mean to conserve vertebrate species. And you could use successful conservation as a proxy for recovery. At least that's what I'm going to do. And it's about resilience. It's about being functional. It's about being much more than just just being in representative systems or having viable populations at small levels. And that it talked about very much about the notion of risk prevention being really defining most recovery efforts, and that really it is much more than just preventing extinction, that it's really about embracing the full scope of the species and what it used to be in that system. And in fact, that has to play out at various scales. And if you look at just at the demographically viable or maintaining genetic integrity, you're really looking just at the population level. You're really not. That's a pretty limited perspective. But in order to really undertake risk management and ensure that these species are recovered in the sense that they're not bouncing on and off endangered species lists and being in crisis mode perpetually, then you've got to be looking at other features that deal with their functional role and actually how replicated and resilient they are. This just says some of the same things that I have been saying. I'll zip through this in a minute. Just again, the demographic viability and genetic integrity really comes out of the very first types of scholarship that came out of the conservation biology discipline, and was founded off island biogeography, but it also was really very focused on what is the minimum viable population to be maintained so that you don't go extinct. And there were small numbers like 500 and so, and they were trying to get rules of thumb and such, and it was a particularly limited perspective. But then with some research that started sprouting in the 80s and beyond, looking at how particular species, the abundance and the relative abundance that they displayed, levels in any particular ecosystem in which way they were part, played a large role in terms of how other species would be able to both behave and their conservation status. And so one of the classic examples, of course, are sea otters, where the disappearance of sea otters led to cascading events that affected the condition of the kelp forests, and that this was a very complex relationship that really could be explained by the entry or exit of this one top predator, because as soon as it came back, those systems actually, in a very elegant way, restored themselves. And of course, I'm simplifying the story intensely, and there are very few other great textbook examples like that. But there is a growing knowledge of the idea of this functional role that many of these species can play. Quantifying it, describing it, proving it, and all that is definitely much more elusive. But ecological functionality is absolutely something that needs to be kept an eye on. And then redundancy, representation, and resilience, which is sometimes called the 3 Rs, deal with going much more than just trying to maintain the status quo if there has been lots of decline and lots of depletion of the species, but then really be able to keep your eye on retention of much more complex aspects that relate to everything from the genetic to its adaptive capabilities, and then of course these new concepts of resilience. These are all really theoretical. I mean, if they look theoretical to you, they are. And understanding what those targets are and being able to quantify them is not something that there's been much success on. But the notion is that there is the knowledge that we have to be building higher than some of the parameters that we've more successfully quantified, like minimum viable populations and some of the genetic aspects. So how much recovery is enough? Well, conceptually you need to safeguard against future threats and understand those risks to the species' long-term persistence. But again, it's a theoretical construct. When you push comes to shove at the table, when you're actually making recovery goals and you're looking at trade-offs, this kind of concept doesn't get you very far. And so that is a reality. We don't have the knowledge to set targets most of the time. We know, for example, that these 3 species, one, bison I've already spoken about, but sets of species, but bats and bees are new to this scene in the sense of the large declines that they've experienced. We know that these are animals that perform ecological functions such as pollination, insect eating, such. But we have no idea how important that is, how critical, what will happen when it's gone, what can replace it. All these things we have no idea about in any kind of quantitative sense. But yet there is the appreciation that if you just have limited perspective on recovery, you won't get to that point given the huge declines that have taken place. And so one notion is, well, why don't you just delist, and that means recovery. And certainly that is something that you see a lot of in recovery strategies. Success will mean as soon as they do not qualify for the status by which they were listed. So they stop declining to any certain amount. That means that, or they live in a bit bigger area than the thresholds that dictate the IUCN criteria, then that is a success. And certainly you do see that in some recovery strategies. But there is a real difference between the concept of recovery that I'm trying to push here and the notion of preventing risk, extinction risk, which the IUCN Red List categories in any case are intended to reflect. And they really, more often than not, define the species that are really closer to the end point in a downward trajectory than up at the top. And that's just the nature of the beast. And that's also the way that those the criteria are set up and processes as well. And so the consequences of equating delisting with recovery are potentially significant in the sense that your ambitions are much diminished from what you know, although cannot necessarily quantify, to be a real state of recovery. And then you also have a situation where you might have a species bouncing on and off the list because they don't achieve any measure of security. And to illustrate a terrific example that most will be familiar with, I mean, the Atlantic cod was an animal that lived at very, very high abundances just over 100 years ago, and has been now in the last 30, 40 years at very, very low abundances by comparison. And it was assessed as endangered under the A criterion, which is about decline over 3 generations. And it met the thresholds for that. And so, but the next time that we assess this, it's very possible that that window means that if it's been declining over 27 years already, that it won't actually meet the criteria for endangered anymore. Does that mean that it's been recovered? I'll let you answer that. And just in closing, the notion of depleting the common and devaluing the common because of, and I'm talking about the most common species, and this is something that Kevin Gaston has written a number of incredibly eloquent papers about, looking at why do we not pay much attention to the widespread common species, and why when they do undergo declines, why don't we pay attention to what that means that, in terms of these huge levels that they are then, given the percentage of declines that they are then reduced to, and what that actually means. And that is a critical issue. And another paper by Kent Redford just recently said abundance is a buffer from perturbation, whereas rarity is a perpetual vulnerability. And that's something that we have to keep in mind as we construct recovery. So just in closing, my take-home messages are simple. Extinction and recovery are very central concepts in legislation. One is defined, one isn't. And the way in which they are both defined and not defined both impose constraints on listing and recovery, and sort of our whole management of species at risk. And I hope that's a point that has come across. But second, preventing extinction is the primary goal of most statutes. But it also really influences perceptions of successful recovery, because that's what we have our mind on most of the time. And third, because of these narrow perceptions that are not keeping up with the current ecological understanding, and that's difficult because we are a slave also to our legislation. This will mostly promote rather than prevent incremental erosion of biodiversity in the end. And we need to be careful of these narrow perspectives and be better versed in really understanding trying to bring that together with more enhanced ecological understanding of what's happening out there. And that's all I have to say. Thank you very much.
We have time for questions, of course. So please feel free to go ahead, please.
Hi.
Hi. Well, I want to thank you for the beautiful clarity of your presentation.
Simple.
Thank you so much. I was particularly taken with what you were saying about risk and the ongoing vulnerability to risk. And I'm wondering if there are studies on the effects of stress in individuals, I would presume, but how that may impact on prospects when creatures are in that diagram area where the stress or the risk is ongoing.
There are some studies that are starting to go and have been undertaken, particularly on looking at stress and in various in individuals of various populations, and that's becoming more and more common to do. And although I'm not familiar with a lot of them, those that I am familiar with do show that under certain conditions, stress hormones are elevated, and it's not far leap to have that also ultimately affect things like reproductive success or just general stress on animals can lead to the same stuff that we worry about as humans, that you're more and more vigilant. For example, you're spending less time feeding, you're spending less time taking care of yourself, you're running more, you're swatting insects more, so all of these, depending on what kind of environment you're in, all these factors can compound, and I think there's a lot of analogies to the considerably richer body of research on stress on humans. But that is something that that researchers are getting more and more focused on. There is more and more of a focus of that. The techniques have ripened both to be able to measure the hormones, but more importantly to collect the samples at the appropriate time, which eluded wildlife research for a while. So that's gotten more sophisticated as well and has allowed a little bit better view of that. Yeah.
Yeah, so just kind of thinking out loud here, I really enjoyed your talk. Thank you very much, very informative. One thing I was just thinking about is sort of about the theoretical robustness of this notion of functional extinction, and particularly as you're talking, I'm thinking like, well, what ultimately would constitute functional extinction? It must be the case that no matter the population, if there's any variability in the population, that's got to shift the function of any given species within the ecosystem. Right, so and I was likening this to something like sandpaper, for instance. If you have like an 80 grit sandpaper, you'll do some functioning, you'll be able to take off a lot of wood, right? But if you then shift to 160 grit sandpaper, that's going to take off a lot less wood, right? This is like comparable to otters in a certain respect, right? They're just going to do a lot less work for the ecosystem function. So in some respect, any changes, right, are going to amount to something like functional extinction, right?
Yeah, I mean, it's definitely just a concept. I don't think it has been very rigorously tested, or, but certainly it's a scale issue, like you say. But also there is some perception that some functions can only be done at high abundance, and that there is some kind of abundance level where that function won't, even if it's a little bit, it doesn't perform.
It gets worrisome, like near the end when you were quoting whoever it was you were quoting, who said that it serves as a buffer or something like that. An abundance serves as a buffer against other kind of vulnerabilities and whatnot. I mean, it's worrisome because these vulnerabilities exist across the entire range, across the entire functional range, right? So it's always going to be the case that they're not really serving as a buffer. They're always going to be vulnerable. Wouldn't that be true?
Well, we are talking about, when we are talking about extinction, we're talking about the whole range. So, all of this would be having to happen across the whole range for that to be occurring. So if you have a species that has a wide range and that phenomenon is only occurring in a small area, you're not going to be talking about functional extinction in that kind of situation. So we're, in particular, where this concept, where that quote came from, was in relation to common species that were until recently common and have been subject to pervasive threats that have actually affected the entire range at the same time and have had profound declines. And there are more than we realize. There are quite a few of examples of that, from birds to bats to bees. And there are many examples where that hasn't happened, of course. But so really that quote was very much about those species in particular and the notion of commonality and the value of common species, and particularly the worry that should occur when a common species that may play a functional role, and in some cases you can imagine or document it better than others, have experienced those pervasive declines.
You have a question here?
Yeah.
Can you just you speak up or stand up so that people in the back?
So I was wondering if you could give us any, I know this is a problem, but I also know there's a lot of recovery strategies. So Redford talks about multiple populations across the natural range of a species.
Mm-hmm.
And are there any case studies where people have actually tried to operationalize natural range for species in Canada, given that the range is shrinking, we convert habitat?
Well, in Canada and under the Species at Risk Act, this gets also tied up with, which I removed those slides because of time, with the of what's feasible or not, and that is a whole concept that takes you down another garden path in terms of also not well defined, but also does get played about in terms of then this natural range of variability is constrained by some of that, whether or not it's going to be biologically or technically feasible. So at its root, you could say, okay, that means that you recover the whole historic range of the species. But then, everybody in this room is saying, well, that's impossible for a number of them. And so it's debatable whether that biological and technical feasibility relates to that, sort of constraint that's imposed.
Just in the back there.
Yeah.
So in other fields like medicine, recovery or remissions have been very well defined. Thinking of cancer, for instance. Why is it that in this specific case of wildlife, term like recovery, which is at the core of the act we are talking about, has yet to be defined?
I don't know the reason to that. But I mean, I'm being glib.
Because the law is not defined, it's not that they're not defined per every program. There's not one general definition, which might actually be a good idea, some might say.
Yeah, I mean, we are. Your question literally, why did the writers of the Act not define recovery? And the only thing I can say is that the attempts to do so at the level, at least in this circumstance, with respect to the Canada Species at Risk Act, which I'm familiar, all attempts have been thwarted. While it's very, very difficult to do this, because they have been thwarted, meaning you get to a certain point and you cannot reach agreement, or you're trying to wrestle between scientific definitions of the science and then some of the political aspects as well. And so there hasn't been a policy that a lot of interest in hasn't emerged, but there are probably many complicated reasons for it, but probably the most fundamental one is that it's very difficult to do and to reach agreement.
It takes 50 years to define a species. So my question is, how many years does it take to define it in terms of being sustainable?
I think it totally depends on the species.
I think in practice, we're in a rush to
Yeah.
declare things recovered.
We're definitely, the boxed checking, I mean, certainly there's been a big debate in Ontario about certain changes that were done to the Endangered Species Act in the last 8 months, and the minister has come back with, but there's been 9 species that have been taken off the list, and every time that's the statement that's been made. In some cases it's just because there's more information, but they're taken off the list. And so recovery is extremely important, obviously, because if you just have more and more species that get put on the list and none get recovered, then there's something wrong with what's going on about effectiveness. Yeah.
As I read your take-home message, it seems to me that biodiversity appears as the overarching value. And I wonder if you could say something about what makes biodiversity valuable as related to, or as opposed to, for example, the preservation of species value. Conceivably, in some cases, the elimination of species could contribute to biodiversity.
Yeah. Well, did everyone hear that? It's the main way I want to answer your question is to say that we are a slave to our tools, and our tools are these individual species focused, what do you call, the endangered species legislation that really enslave us to kind of an individual species take. And then by virtue of being slave to that, then everything is done on a piecemeal basis, that every single species is tackled separately. And that is to the detriment of the broader issue of biodiversity, which is much more complex than species are only part of. But so far, our answer to biodiversity decline in each of the jurisdictions related, for example, to the Convention of Biological Diversity, even though it's recognized that it's much more than species, most of the answers that we've come up with at the jurisdictional level at each country relate to species acts and that as the vehicle for taking care of biodiversity writ large, but it's not sufficient. And biodiversity has many other levels besides species, notably genetic and ecosystem. And even though there's lots of talk about going at an ecosystem approach, practically speaking, that often just means that you get at a higher level and you dilute what's happening below, and you're not monitoring what's happening below. And often the species are the metrics that you need for monitoring, or at least one metric for that. So my final comment about that is just that the species perspective is very limited. But it is what the legislation that we have, and we really need to be keeping our eye on biodiversity writ large.
Any other questions? Okay, well, I think you'll join me in.
Okay.